The topic today is graphing polynomial functions. And you see I have two situations here. I have a polynomial on the left side of the screen, which is in factored form. I have another polynomial on the right side of the screen, which is in not factored form. And we're going to talk about how you would get an idea of what shape that graph would be. We're not going to graph every single aspect of it, like no x-intercepts, no y-intercepts. All I'm going to talk about here is what's called the end behavior. Okay, the end behavior is what the graph looks like far away from the center. Like, where is it going as you get into very, very big values of x? Is it going up or down? And we have these four categories. They're called positive even, negative odd, negative even, and positive odd. And the reason they're named those things is because they depend on the power function of our polynomial. If the power function is positive even, it goes up and up. Okay. What I mean by positive even is this is things like, I don't know, 2x to the fourth, or 3x squared, or 17x to the sixth, right? You notice all of these are positive coefficients, and they all have even exponents. Likewise, negative odd would be things like negative 2x to the third, negative 3x to the fifth. See, these exponents have to be odd, and the coefficient in front, I don't care if it's even or not, but it has to be a negative number. And that exponent has to be odd. So you can see the pattern here. I'm going to talk about how do you get the power function, because in factored form, it's not trivial. You don't just look at it and know what it is. What you have to do here is imagine that you were going to multiply this polynomial here out so that it's no longer in factored form, but more like this guy in standard form. That's not even standard form, but we can't have all these parentheses in here. They get in our way from seeing what the power function is. Now, the trick that I go over in class is fairly straightforward. If you want to know what the biggest power of x is, well, all you have to do is ignore everything that's not x when you're doing the multiplication. Okay? So the way we do that is we take this polynomial, and let's just write it out here. You understand, I'm not going to multiply the whole thing. That would take a lot of time. All I'm going to do is cross out the parts that are not important to me. So I'm not going to worry about this positive 2. I'm not going to worry about this negative 3, because those all describe lower powers of x when you carry out the multiplication. What I'm doing right here is only focusing on the powers that will lead to the strongest x. So this is going to be 2x times negative x squared. Well, negative x squared is just x squared. So we can write it like this. That's 2x times x squared. And here we've still got that negative 3x. Well, this isn't too bad. I can count the exponents and see I've got 1 here, 2 in the middle, 1 on the end. So this is going to be some kind of an x to the fourth. Okay, and it looks like the coefficients are 2. There's a 1 in here. 2 times 1 times negative 3, so that'll be negative 6. So the power function is negative 6x to the fourth. The full polynomial, if I had multiplied it all out, would have been a whole bunch of other stuff I just don't care about. So which one of these end behaviors is it? Well, this is negative even, right? Negative 6, and the exponent is even. So there we go. Now, the standard form is much easier. For end behavior, we love standard form, because all I have to do is decide if this thing, well, okay, this isn't in standard form. It's not factored, though, and that's still a great win. Let's put this in standard form, okay? If you remember what standard form is, that's when you have the strongest power of x on the left, and then it's descending exponents from there. So it looks like the strongest power of x on this guy is 4x to the 7th. Okay, and then I've got minus x to the 6th. And, you know, a whole bunch of stuff I don't really care about. All I care about is that power function. So this is 4x to the 7th. We see this one is positive odd, right? Positive coefficient, odd exponent. So that's going to be this end behavior right here.